I'm Kazuya Otake from Nagoya University. I'm going to talk about tactile texture rendering for electrostatic friction displays, incorporation of low-frequency friction model and high-frequency texture model. An electrostatic friction display controls the electrostatic attractive force between the finger pad and the panel. It is suitable for presenting fine textures. In previous data-driven models for rendering textures, mainly the high-frequency texture component were used. However, since the low-frequency friction component also contains the material information, both frequency components should be considered. Our objective is to improve texture quality by combining two types of models to cover a wide frequency range. One of them is a physical model for the low-frequency component, and the other is a statistical model for the high-frequency texture component. We measure the coefficient of friction while a finger lies on a texture. Then, the coefficient of friction was divided into low and high-frequency components. For example, the left figure shows a coefficient of friction of denim. The central and right one shows its low and high-frequency components. The low-frequency friction component is rendered by a physical model, which responds to the finger load and the velocity. The high-frequency friction component is rendered by a statistical model, autoregression model, that preserves frequency characteristics of the coefficient of friction. To compare the two simulus conditions, we conducted a user study. We investigated whether the combination of low and high frequency stimuli improves the quality of texture. We compared two simulus conditions. In one condition, low and high frequency components were incorporated. In another condition, only the low frequency component was presented. The experiment was a two-alternative task. Participants selected the more realistic stimulus from the two stimulus conditions. 4 types of materials, leather, cork, denim, and wood, were presented. This shows the mean proportions of participant answers and their 95% confidence interval. Blue bar shows the proportions that the combined model was selected as more realistic, and orange bar shows the proportions of friction model only. For cork and denim, the combined model was preferred. In contrast, there was no significant difference between the two stimulus conditions for the leather and wood. So, the effect of the method depends on the types of texture. In summary, the combination of physical model for the low-frequency component and statistical model for the high-frequency component improved the realism of virtual textures. Thank you for listening.